This session is for semester 7 computer science and engineering students for the subject big data analytics. The course code is PE736CS. Let us look at the syllabus contents. The course title is Big Data Analytics. The course objectives are understanding big data, understanding SQL, NoSQL, understanding Hadoop and related tools. The course outcomes are use cases of big data, NoSQL, installation of Hadoop, configuring HDFS, apply MapReduce using Hadoop, apply tools such as HBase, Zookeeper, Pig and Hive for big data analytics. Let us give a cursory glance at the syllabus. Unit 1, Big Data Analytics. Unit 2, Apache Hadoop Distributed File System. Unit 3, Developing a MapReduce application. Unit 4, Pig and Hive. Unit 5, HBase and Zookeeper. The prescribed textbooks are by the author Tom White, Eric Sammer, Vignesh Prajapati, E. Capriano. Let us look at the first unit syllabus for the subject Big Data Analytics. The first unit consists of basics of big data analytics, including definitions, how they are affecting our lives, data sizes, challenges of big data, what are the 5 E's, detailed data, types of data, business intelligence, traditional big data, data warehouse architecture, analysis tools, Hadoop environment and its components. So, in our today's introductory session, let us focus on the 3 words of the course title, Big Data and Analytics. Let us try to decipher them through our introductory session. So, few of the important statistics here, like if you look at this first table, it is saying how much amount of data is generated every minute, the number of messages by WhatsApp users, the messages shared by Facebook users, photos shared by Facebook users, Instagram stories by users every minute. If you look at the estimated data consumption chart, it is starting with 74 zettabytes in 2021 to 2024 zettabytes, 149 zettabytes in 2024. So it means it's an era of zettabytes, it's an era of big data. Initially, there was no proper definition of big data. Big data meant huge data, large volume of data. To know better the term big data, we need to understand its features and sub-features. And those can be understood through its 5 most common characteristics denoted by 5 V's. The 5 V's are variety, volume, velocity, veracity and value. So when we say big data, it is a collection of a huge data set. The data is received from multiple varied sources. Big data is rapid acceleration in quantity and quality of available and relevant data. It uses advanced capturing and storing technologies based on 3 V's, that is volume, velocity and veracity. When I say big data, I am speaking about anything beyond 2500 petabytes or more. When I am saying petabytes, I am speaking about units of memory, starting with bit, nibble, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, yottabyte. So big data comprises of large size complicated data sets. It uses complicated processes. It uses various techniques to explore hidden values from the varied and complicated big data sets. Big data actually is an outcome of technology revolution, as Millions of people are using smart devices and technologies. This huge data generation, regular, traditional, conventional databases, handling techniques cannot manage this big data. So, big data is generated through sensors, smart devices, imaging, laboratory studies, administrative data. Big data is HAZE, heterogeneous, autonomous, complex, and evolving. Heterogeneous indicates diversity of data, volume of data. Why diverse data? Because the collectors of the data are diverse. They may use their own schemata, their own protocol. Why autonomous? Because data is coming from different sources. As this volume increases, complexity of the data becomes more difficult. The analysis and classification becomes more difficult. So we could decipher big data term from the syllabus title Big Data Analytics. Let us try to dig deeper into analytics terminology. So when I'm speaking about analytics, I'm usually speaking about business analytics. And business analytics indicates faster decision making, better insights, better actionable items, better problem solving, finding new and novel information, usage of simulation tools, expert systems, optimizations. Companies, organizations, firms are using analytics or applying analytics to describe, to predict and optimize their business performance. Initially, business intelligence terminology was used, now it is business analytics. Customer intelligence is replaced by customer analytics. Web mining is replaced by web analytics. And knowledge discovery is replaced by data analytics. Why this sudden popularity of analytics? Customers, global competition, paradigm shift in data gathering and decision making. Previously it was intuition based, leadership based, now it is fact based. This is happening at the organization level because they are collecting lot of evidences, lot of hard facts for better decision making. What are the applications? Sentiment analysis, fraud detection, product pricing, employee retention, there can be many. What are the hurdles? The hurdles can be culture, challenges of handling big data, cost, security and privacy. Coming to the four types of analytics, we have descriptive analytics, which is summarizing the existing data using some visual cues, graphs. They'll be helping in deriving patterns, drawing interpretations, going for better strategies. This is the most frequent type of analytics use. The second type of analytics is diagnostic analytics, which speaks about what happened and why. And usually the resultant of diagnostic analytics is a dashboard. The third type of analytics is predictive analytics. It uses statistical models, machine learning techniques. Say for example in healthcare domain, it may be using codependent variables like individuals' health, habits, diets, genetic composition to predict health risk or health issues. The last type of analytics is prescriptive analytics, which is used to recommend some course of action after analysis of the data. An example of prescriptive analytics can be a Uber driver getting an easier route using Gmap. He'll be getting his best route by considering the various parameters like distance, pickup, destination, traffic constraint, ECT. So this was the initial introductory session to decipher the title by name Big Data Analytics. This subject is meant for semester 7 computer science and engineering students. Thank you.